Hi, my name is Sarah Utterback. I'm going to be discussing electricity and magnets in the future. So basically, I'm just going to be kind of talking about how those two things are likely to change in the future as developments in research are made, and how those developments can change the lives of many, many people who use these every day. So, just kind of a basic introduction to some of the topics that I'm going to be referencing heavily throughout the presentation are electricity is um, the transmission of energy through wires. Um, we use this all the time to operate machines and devices that we use constantly in our everyday lives. Uh, Electricity is really considered a basic necessity in the United States because it is used so heavily. And that's pretty much just the definition of electricity that will be referenced throughout this presentation. Magnetism is the force that causes attraction and repulsion of certain materials. Um, and when these two are linked, which happens constantly, the result is called electromagnetics. And so, what this pretty much does, the common results, is that electric currents cause magnetic fields to be generated outside of the wire in electricity. Um, just kind of in a circular pattern, and changing magnetic fields also produce an electric current. So the discoveries of electricity and magnetism were obviously very, very massive strides for humanity, and they led to numerous other developments in technology that people use every single day. And recent research has yielded revolutionary advancements in these um, that result in increased energy efficiency, intelligent manufacturing, which can lead to increased production of goods, uh, better data writing, better medical technology, and a lot of improvements in the transportation industry as well. So, the uses of electricity and magnetism are vast already, but they will only continue to grow and become more and more widely used. So, to begin with an electric improvement, we are going to discuss some improvements in semiconductors. So, these really are used in just electronics that people use every day because they contain semiconductors, or most of them do anyway. So, what researchers are working on now is adding the material silicon carbide to semiconductors. This will increase their strength and their resistance to heat. This makes for a far cleaner and much more sustainable source of energy production, which is what you'll actually see that a lot of these things do is create um, clean, sustainable energy, which is really, really important for the future. Um, in addition, these semiconductor improvements can result in increased switching speeds and cut heat loss, which will really just improve performance in everyday electronics. So General Electric is working on adding an electric sensor to its manufacturing equipment that is going to result in a kind of intelligent manufacturing, um, meaning that the machines can communicate with one another. So what's going to happen is that this sensor is going to be threaded through all the machines. Um, the machines will be able to talk to one another, which will result in faster work, less downtime, and decreased waste, because the machines will get to talk to each other and get to really synchronize their actions and when they need to be doing what, so that they can increase their efficiency as much as possible. Um, these improvements could not only lead to the improvements for GE's actual production, but obviously when production is improved, you see improved selling. So these improvements could lead to increased availability of the products, higher quality of the products, and lower costs. The reason higher quality is because the machines will also have the ability to alert the production staff at the GE plants to when there is an issue within the machines, and so that they can actually catch many more errors instead of those products going out to the public. And it can also allow them to increase their speed in realizing those errors and getting the chance to go fix them. So another new material that links magnetics and electricity is called multiferroics. This causes magnetic oscillation, which is really important in data storage. Typically, magnetics are used to store data, and then data writing is done electronically, but these multiferroics allow both to take place in one location rather than having to do data storage in magnetics and writing in electronics. So this is going to really increase the speed and efficiency of electronics devices that require data writing and storage. So you're going to see a lot of improvements in hard drives and other things that store data. So several improvements throughout the rest of the presentation are going to be medical, which is really, really cool to see kind of physics and medicine intertwine. So one of these is magnetic cell cultures. So researchers are working to inject magnetic material into cell cultures in petri dishes, and then add a magnet to the top of the petri dish so that the cell culture can grow upward and be suspended in the liquid in the petri dish rather than growing out into a flat culture. This 3D structure would be a lot more realistic to a real life cell, thus improving research and the ability to detect, certain viruses or pathogens or whatever in the culture. In the future, this type of technology could also be carried over to growing more realistic organs in the lab, which would be really, really beneficial to medical research, obviously, and medical student practice as they got the chance to really inspect these organs that they're, learning about. So, sorry. As I'm sure you know, American football has a dangerously high number of concussions and head injuries, and that's really come to light in recent years as things like CTE and early Alzheimer's have really kind of made their way into aging football players who have had numerous concussions. And so researchers have been really searching for ways to decrease the amount of concussions and make football, a safer sport. So researchers are adapting helmets that are going to be lined with magnets, which would then utilize repulsion as a way to combat head injuries. So basically, this would only be beneficial in head-to-head blows, but what would happen is that as the head blow was beginning to occur, the magnetic repulsion would kick in, and obviously those helmets are slightly repelling each other, which would really slow the G-forces and significantly lessen the impact on the helmets, clashing together, which could really, ideally, significantly lower the number of head injuries and concussions in football. Another medical advancement from magnets are these cancer-detecting pills that are being developed currently. So these pills are being injected with magnetic nanoparticles, and then the pill is swallowed by a patient who is undergoing a, physical or whatever, for whatever reason they're, trying to detect cancer in the patient. And the magnetic nanoparticles would then be released and patrol the bloodstream in the patient in search of cancerous cells. These would then report back to a sensor that is worn on the wrist of the patient, and then that sensor obviously would raise alert that cancerous cells had been detected, and ideally these could be detected much earlier than if the patient had simply started having symptoms of whatever kind of cancer and gone to their doctor about it. So this would be a really a great way to better early detection, which would obviously improve the patient's likelihood of overcoming the cancer and the doctor's success rate in treating it. So another advancement is automated highway systems for self-driving cars, because self-driving cars are becoming such a source of interest, and people are really looking into going that direction. So these roads would be embedded with magnets that could create an automated highway system for self-driving cars. So this was actually already researched in the past, and it wasn't practical at the time because of how expensive it would be, but Volvo has recently started looking into it again. The cars would include the sensors that would communicate with and be guided by the magnets that were in the road, and this would be far more reliable than other methods of autonomous vehicle control, because the magnets would not be affected by weather or obstacles in the road. So it creates a very safe condition for self-driving cars. So another development in transportation is the magnetic levitational train. This has been done, and Japan has one of the biggest ones that already broke the world record for speed, topping out around 366 miles per hour, speed for a train anyway. And these really are just being considered for expansion and kind of getting them all over the world. Several countries already have them, but seeing them in the U.S. would be really beneficial to commuters, travelers, the environment, and they would really create a lot of jobs and advancements in the business world, because obviously they would have to be built and maintained and run. So that would create a lot of benefits there. But the way they work is that there are magnets in the body of the train and in the rails, and the repulsive forces cause the train to levitate above the rails, which totally eliminates friction, which is part of the reason it allows it to be so fast. And then electromagnets in front of the train pull it along at high speeds. So those could be really, really beneficial. So in conclusion, just these developments in magnetics and electricity can really have a significant impact on the future in lots of different sectors. Some of the potential benefits include improved semiconductor performance, intelligent manufacturing, improved hard drive performance, 3D cell cultures, improved football helmets for concussion prevention, magnetic pills for early cancer detection, improved highway systems for autonomous vehicles, super high-speed magnetic levitational trains. So basically there are lots and lots of benefits to the research that's being done in magnetics and electricity, and just further progressing what is already such a big deal to our country. So thank you so much for listening.